Hello viewers, in today's session we are going to discuss another important problem from application of derivatives, and here we are going to take up an important problem from the concept of increasing and decreasing functions. So here we have to prove that this function f of x, that is 2 times cos x, and here cos square x over 2, is a decreasing function on this interval, that is 0 to pi by 2. So in order to prove that this function f of x is a decreasing function on this interval, we have to take help of the concept of derivatives, right? So here we'll take up the definition of decreasing function in terms of derivatives. So suppose we have a function, say y is equal to f of x, which is defined in some domain D, and if f of x is a continuous function in the interval, say a comma b, and it is derivable in the open interval a comma b, then this function is said to be a decreasing function if the derivative, that is f prime of x, is less than 0 for all x belonging to this interval, that is a comma b. So dy over dx has to be a negative quantity, or it is less than 0 for all x belonging to a comma b. So here we'll utilize this definition of decreasing function. So let us first rewrite this function f of x using an important trigonometric identity. So let us first write f of x as here we have 2 cos x, and here we have cos square x over 2. Now from trigonometry we know that cosine 2 theta is equal to 2 cos square theta minus 1. So taking minus 1 to this side, we have cos 1 plus cos 2 theta is equal to 2 cos square theta. Now if we replace theta by 2, then we have this expression 1 plus cos theta is equal to 2 times cos square theta over 2. So here we have 2 cos x cos square x over 2. So let us combine 2 and cos square x over 2. So here we have 2 cos square x over 2, and here we have cos of x. So now using this identity, that is 1 plus cos theta is equal to 2 times cos square theta over 2, we can now replace 2 cos square x by 2 by 1 plus cos x, right? And now if we multiply 1 plus cos x with cos x, then we have cosine x times 1 is cosine x, then we have here cos square x. So now our function f of x, it can be written like this using this identity, right? So now let us find out the derivative of f of x with respect to x. So f prime of x is equal to d by dx of cosine x, and then we have d by dx of cos square x. Now the derivative of cos x is minus sine x, and here we have the derivative of cos square x as 2 cos x, and then by chain rule the derivative of cos x is minus sine x. So now we have minus sine x, and here we have minus 2 sine x cos x. So now let us use this identity, that is sine 2 theta is equal to 2 sine theta cos theta. So here we can now write minus sine x, and then we have minus sine 2x. Now taking the negative sign common here, we have minus, then in the within the brackets we have sine x plus sine 2x. So the derivative of f of x is given by this expression, and now for fx to be a decreasing function, the derivative should be less than 0. So now let us see this interval. So here x belongs to 0 to pi by 2. So this suggests that x should be greater than 0 but less than pi by 2. Now here we have the combination of two terms, that is the sum of sine x and sine 2x, right? And when x it is greater than 0 but less than pi by 2, it implies that we are in the first quadrant, right? And from trigonometry we know that the sine function is positive in the first and second quadrant, and it is negative in the third and fourth quadrant. So here we have pi by 2, here we have pi, this is 3 pi by 2, and here we have 2 pi. So according to the sign convention of trigonometric functions in the four quadrants, the sine function is positive in the first and in the second quadrant, that is from 0 to pi the sine function is positive, and from pi to 2 pi, that is in the third and fourth quadrant, the sine function is negative. So here we are going to decide the sign of f prime of x using the sign convention for the sine function, right? Because here we have the sum of two sine functions. So now we have x greater than 0 but less than pi by 2. So let us multiply this inequality throughout by 2, because here we have sine 2x. So we need to find out the interval for the angle 2x. So here we have 0, that is 2 times 0 is 0. Here we have 2x, and here we have pi, because 2 and 2 get cancelled. And this inequality suggests that x belongs to the first quadrant, that is from 0 to pi by 2, and this inequality suggests that 2x belongs to the interval or the quadrant that is either first quadrant or second quadrant. So here we have first or second, right? So in both the cases, that is when x belongs to the first quadrant and 2x belongs to the interval 0 to pi, sine x and sine 2x both are going to be a positive, right? So let us once again explain it. So here we have sine x, and here we have sine 2x. Now x is greater than 0 but less than pi by 2. So x is in the first quadrant, and in the first quadrant sine x is positive, right? So this quantity is positive, and 2x, when we multiply this inequality by 2, then we have 2x greater than or less than pi. So 2x belongs to either in the first quadrant or in the second quadrant. So sine 2x is again positive, because 2x lies in the interval that is 0 to pi. So here we have the sum of two positive numbers, right, for all x belonging to this interval. So now we can write f prime of x is equal to minus, and here we have a positive number for all x belonging to the interval 0 to pi by 2, and here sine 2x is again a positive number. So we have minus, and the sum of two positive numbers is positive, and when we multiply negative and positive, then here we get a negative sign, and this suggests that f prime of x is less than 0. So this function f of x is a decreasing function on this interval 0 to pi by 2, because f prime of x is equal to a negative number for all x belonging to 0 to pi by 2. That is f prime of x is less than 0 for all x belonging to 0 to pi by 2. So as per the definition of a decreasing function, a function is said to be a decreasing function if f prime of x is less than 0 for all x belonging to the interval a comma b. So this is how we can prove that this function is decreasing function on this interval.